In the department of Meta, Colombia, 17 kilometers from the capital of Villavicencio, is the village of Santa Rosa. Rice experimental lines are being selected at the Santa Rosa Experimental Station, there with high levels of resistance to the most important disease of rice worldwide, rice blast. Since 1983, the Santa Rosa Station, owned by the National Rice Growers Federation of Colombia, FEDEARROZ, and supported by rice breeding programs from the Alliance of Bioversity International and CIAT, FLAR, and their partners, have utilized the unique environmental conditions there to facilitate the improvement and development of rice varieties resistant to diseases, mainly to rice blast, but also other serious diseases that limit maximum yields of rice grain. Due to the Santa Rosa environment, the breeding program can implement an effective and environmentally friendly control strategy of disease resistance, breeding to reduce yield losses and mitigate the environmental impact caused by the use of certain fungicides. This is due to the environmental conditions of the site where the center is located, which are ideal for the high natural inoculum pressure of the rice blast disease fungal pathogen during the rainy season. Thus, Santa Rosa is a strategic site for selecting rice germplasm with resistance to the damage caused by this fungus and other pathogens present in these fields. The establishment of trials for the evaluation of rice blast starts with field preparation, the selection of the genotypes to be evaluated in the trial, seed preparation, and its subsequent sowing in a field design that facilitates disease development and ease of selection of resistant rice plants. Trials have a blast spreader zone made up of a mixture of varieties with different degrees of blast disease susceptibility, which disseminates the disease to the genotypes being evaluated. The spreaders act as traps to capture pathogen spores in the environment. The spores germinate on the spreader row plants, reproduce to produce more spores, and continue to increase disease until an epidemic of blast results. If the spreaders do not become highly diseased, it means the conditions are not favorable for pathogen reproduction, which prevents good disease pressure. In this case, the degree of resistance shown by the genotypes under evaluation would be unreliable. This rarely occurs at the Santa Rosa Station. Disease incidence can also be measured by the degree of infection on the very susceptible variety Fanny, which serves as an indicator of the level of the epidemic. The genotypes are subject to evaluation at vegetative and reproductive stages using the following rice blast rating scale. For this stage, 3 leaf evaluations are performed, spaced weekly throughout the seedling to tillering stage. During the evaluations, the leaf blast rating scale will be used, considering the degrees of injury from 0 to 9 as follows. Rating 0. No lesions are observed. Rating 1. Small brown spots of pinpoint size or larger brown spots without sporulating center. Rating 2. Small roundish to slightly elongated brown spots, necrotic gray lesions about 1–2 millimeters in diameter with a distinct brown margin. Rating 3. Lesion type is the same as grade 2, with a significant number of lesions on the upper leaves. Rating 4. Typical blast lesions on 3 millimeters in size or longer, infecting less than 4% of the leaf area. Rating 5. Typical blast lesions infecting 4 to 10% of the leaf area. Rating 6. Typical blast lesions infecting 11 to 25% of the leaf area. Rating 7. Typical blast lesions infecting 26 to 50% of the leaf area. Rating 8. Typical blast lesions infecting 51 to 75% of the leaf area, and many leaves are dead due to the disease. And rating 9. More than 75% of the leaf area is affected. To ensure higher accurateness at this stage, the evaluator can use the lesion coding system to assess the predominant lesion type on the leaf. After completing all the evaluations at the vegetative stage, the highest rating value obtained for each genotype is taken as a reference. Based on this reference rating, the most resistant genotypes are selected. At this stage, the panicle and its parts are evaluated: panicle axis, node, uppermost internode, primary branches, secondary branches, and pedicels. The evaluation is conducted when the plant is in the DOS stage, following the panicle blast lesion rating scale as follows. Rating 1. Lesions on several pedicels or secondary branches. Rating 3. Lesions on a few primary branches or on the middle part of panicle axis. Rating 5. Lesions partially around the vase or node, on the uppermost internode, or on the lower part of panicle axis near the base. Rating 7. Lesion completely around panicle base, on the uppermost internode, on panicle axis near base, with more than 30% of field grains. And rating 9. Lesion completely around panicle base, on the uppermost internode or panicle axis near base, with less than 30% of field grains. After the evaluation, genotypes with acceptable ratings are selected and harvested to produce advanced segregating lines to be evaluated in national rice programs in Latin America and perhaps parents for future hybridizations. This is how the Santa Rosa Rice Experimental Station contributes to the development of rice to obtain resistant varieties targeting the mitigation of yield losses caused by devastating diseases. All this with the purpose of achieving a more sustainable and productive agriculture requiring less use of agrochemicals, which will enhance farmer incomes and benefit a sustainable rice harvest for the people of Latin America.